Today we need to talk about a very important theorem, especially in pre-calculus and calculus, and it's the intermediate value theorem. It's not real complicated, but it is important. If we look at a function, let's say that I've got a nice increasing function, and I look at that x coordinate a, then remember what this value is. How could I get this value up here? If this x coordinate is a, what would this value be up here? How could I find it? Wouldn't I just plug it in? Wouldn't it just be, if this function is f of x, then wouldn't this value be f of a? Right? It's a very important concept. I want to make sure that we get that, that function values come from plugging in the x values. And so if this value over here was b, then the value up on the graph would be f of b. Okay, very important that we understand that relationship. What the intermediate value theorem says is that if I have a continuous function, that this function takes on all, this is f of b. Let me kind of label it over here. This is f of a. And up here looks like that's about f of b. The intermediate value theorem says that this function, if it's continuous, it takes on all the values in between here, or it takes on all of the y values between f of a and f of b. There's no gaps. Okay? So let's kind of write this theorem down. I'll try to summarize it in a way that you can understand it. Or in other words, let's add something to my graph here. I want to add something. I'll use purple. There has to be a x-coordinate c. Okay, if this intermediate value theorem is true, there has to be a c that gives me an f of c that is in between these two. Okay? There has to be, according to the intermediate value theorem, there has to be some value in between. All right? So, how can we say this theorem in a way that we can understand it? If A is less than C is less than B, okay, we can say if, then there has to be a point C such that f of a is less than f of c is less than f of b. Has to be. Okay, if the function is continuous and there's no gaps and no holes, it takes on, like we said, it takes on all of the values in between. All right? So there has to be at least one place that's in between. All right? That's kind of what that's why we get the intermediate idea. Okay? It's in between the other two values. Now, let's expand this idea a little bit. The problems you're going to be doing are pretty easy. So we really need to understand the theorem first. Let's say that my function was this. And let's say that here's my function f of x. And this is where this theorem really comes in handy. Let's say that I know that this x coordinate is 2 and this y coordinate right here is negative 5. Okay? Let's just pretend. And then let's say that I come over, maybe this is 3, this is 4, this is 5, and this is 6. And I come over to 6, and I come up to its function value, and I know that that value is, let's say, 3. Okay? So let's just kind of talk about this for a minute. I know that f of 2 is negative 5, and I know that f of 6 is equal to 3. Here's where the intermediate value theorem really comes in handy. Can I guarantee now that there is at least one 0 in between 2 and 6, according to the intermediate value theorem? And the answer is yes. Do you see why? The intermediate value theorem says that it takes on all of the y values between negative 5 and 3. Can I go from negative 5 to 3 without going through 0? I can't. Okay? I have to go through 0 at least in one place. All right? So if I see, watch carefully, if I see the y value change from a negative value to a positive value, I know that there has to be at least one place in between where there's a 0. And that's the way we're going to look at these, is we're going to look at table values. All right? So let's look at an example. Your homework tonight, they're going to say, use the intermediate value theorem, and I'm going to abbreviate with IVT. Use the intermediate value theorem to find intervals 1 unit in length guaranteed to have a 0. And we're going to use the table of the graphing calculator. Okay? You're going to find this is not real hard in terms of the work we do on paper. It's going to be mostly analyzing it. So let's say that my function is 12x cubed minus 32x squared plus 3x plus 5. There's my function. What we're going to do first is we're going to put the function into our graphing calculator. 12x cubed minus 32x squared plus 3x plus 5. Okay? And let's go to our table setup. And starting at negative 6, I need to make sure that this is on independent. I don't want to do ask. I want to make sure my independent is on auto, I mean. And why don't we just start at maybe negative 10. Okay, and let's go to the table now. Now, so far everything's negative. Okay, so I scroll down. What am I looking for? What am I looking for as I do this? I'm looking for a place where there's a jump from a negative function value to a positive function value. Do you see one? Look. I see a couple now. I see on this problem, I see a couple things going on. Let me get this into a place where I can write on it. Okay, if this is my table, all we're doing here is analyzing the table. Look right here. Don't I have a jump from a negative function value to a positive function value? Do you see that? I went from negative 42 to positive 5. So I have found one interval where there has to be a 0. Somewhere between negative 1 and 0, there has to be a 0. There's my first answer. Negative 1 and 0 is an interval where there has to be a 0. Now look what happens. Doesn't it jump again from 5 to negative 12? If I look at the next interval on my table, it jumps from 5, it jumps from a positive value back down to a negative value. There has to be a 0 there. So there's my second interval, 0 to 1. That's the next place where there has to be a 0. And then from 1 to 2, there's no change, is there? What's the next place where there's a 0? 2 to 3. Because it jumps from a negative value back to a positive value. So from 2 to 3, there has to be a 0. All right? Now, we're saying between negative 1 and 0, 0 and 1, and 2 and 3. Let's look at our graph to see if we were right. So you can go back to your graph and kind of confirm that. I'm going to close the window down because I definitely don't need to be very spread out here. Maybe negative 4 to positive 6 is enough. I had some crazy things entered in here. We'll go negative, why don't we go negative 10 to 10 on the y's. And let's just see if what we said was true. Yep. Do you see that that's where the zeros showed up? The places where the x-intercepts were? Remember, a 0 is an x-intercept. All right? We said that there were zeros Look what we said. We said there had to be zeros, get a different color here, between negative 1 and 0. Well, there's a 0. We said there had to be a 0 between 0 and 1. There's another one. And then we said there had to be a 0 between 2 and 3. There's another one. Okay, so the intermediate value theorem proved correct. And we're going to stop there for today.